Hey guys, so this is lesson 1.3. If you have your book, I know William, you've got your book. Chloe, I don't think you have yours, but you should be able to see the online book. I sent you directions on how to go to the website for our book, which is Ed, my friend, or your friend in learning from Clever. If you go there, click on that. This is lesson module 1, which is our first unit, lesson 3. So if you want to follow along, grab a piece of paper, you can do that as well. I don't need you guys to do anything necessarily for this, but I would like you guys to follow along as we work through this together. And then if you're feeling good about this, I'd like you to go ahead, try the unit review, see how you do with that. And then if you're feeling great, go ahead and take your unit module test, module 1 test. That is actually assigned for you along with the review if you look in Ed, Your Friend in Learning, which is our math site. So for this lesson, we want to talk about being able to use absolute value and magnitude to describe real-world situations. So here's a real-world situation. It says this table shows the low temperatures in Nome, Alaska for 5 days in December. And we want to find the distance from 0 to each number. So what we need to do, of course, if we're going to find the distance from 0 to each of those values, is we're going to need to graph them on a number line to see the distance. So I'm going to go here. I'm going to draw a number line here. So we'll draw this a beautiful number line. And of course, if we want a number line, we're going to stop at 0 right in the middle. And then we need to figure out what values we need. So in this case, because looks like 16, negative 16 is going to be our furthest on this side, we'll go ahead and just mirror it on the other side. Looks like negative 16 will be the furthest that either side of these will go. So I'll put negative 16 over here, and we'll do 16 on the other side. And then because I'm lazy and putting 16 hash marks on both sides would take forever, let's just go ahead and do these by 2's. So this, of course, would be 8. Because it's on the negative side, we should mirror that with negative 8. And then we'll just put the hash marks in between. So come on, 8. There we go. 2, 4, 6, of course. And then we have our 8, 10, 12, 14. And then, of course, our next would be 16. And then we'll just mirror this on the other side as well. So 2, 4, 6. There's our 8, 10, 12, 14, and of course 16 is there already. So now we've got our number line, and we just need to graph our points. I'm going to go ahead and change here so we have a different color. So here, our first value is going to be negative 10. So there is 2, 4, 6, 8. There's negative 10. So that was negative 10. We would have negative 15. Of course, would be right here, right before negative 16, since we're going by 2's. Be in between our last 2. Negative 16 itself, put him on the line here too. Then we would have 8. And to do this, we'd go 8 to the right. So we'll count by 2. So 2, 4, 6. There's 8 right here. And last but not least, we would have 3. Which would be just past our 2. So there's one jump over would be 2, and then halfway to the next one would be 3. So here's where 3 would roll. And there are our values. That's how we could model this problem. And then if we want to find the distance from 0 to each number, we could just use our number line and count from 0. So in this case, as we're counting by 2's, we'd have 2 over to 2, and then 1 more over to 3. So we'd go 3 units. For 8, we would go 2, 4, 6, 8 units over to here. For negative 16, we would go 2, 4, 6, 8, 10, 12, 14, 16 over. Now, it's the same, if you've noticed, as the number itself, and we're still moving spaces whether we go left or right, so it doesn't really matter our distance from 0. It's going to be whatever our number is without either the plus or the minus in front of our sign. Again, if we want to go to 15, we just go 2, 4, 6, 8, 10, 12, 14, and 1 half of 1 over, which would be our 15th hop. So as you can see, every time we move, we're moving exactly what the number says here, just like its name. We are just always moving, so we don't have to worry about a negative in this case. So explain how you can find the distance from 0 to each number. This is what you need to be able to do. So go ahead, think that one through. Pause the video if you'd like, and then I'll talk to you about it. So, finding the distance from 0 to a number, all we need to do is look at the name of the number itself, because that's going to tell us how many times we've jumped on the number line to get to that number. The big thing to remember is we don't have to worry about putting a negative or a positive in front of that number, because either way we go, left, right, or number line, we're still moving some spaces. You can't move negative spaces. If you look down here, we've got some matchups. And if you look here, I've actually done all these for you already. But if you look, if I move 10 spaces on my number line, well, if I move to -10 on my number line, I would move 2, 4, 6, 8, 10 spaces. It's going to match up. If I'm moving to +15, I move 15 spaces. That would make sense. But if I move to -16, I don't move negative spaces. I still just move 16 hops. -8. Just moving 8 hops, and 3, of course, I'm moving 3 hops to the right. But regardless of whether they're right or left, we're still moving that many number of spaces. So whatever our number says is the number of spaces we move from 0. So how does that play out in the real world? Why do we need to know this? I mean, it sounds kind of simple to say that we're moving however many spaces our number tells us to move. And that's right. The difference is sometimes we'll have a negative number. And even with a negative number, the number of spaces we move from 0 still remains a positive amount of movement. So we don't have a negative number left over. And this plays out in the real world with things like elevation. So our example here says that the elevations of 4 fish in a lake are shown right here. And a lifeguard is sitting on top of the water. He's right at the water line, and his tower is, and he's at the top of the tower at 6 feet. So we're going to graph the elevations of the 4 fish shown in the lake, and then of course our lifeguard is up here at 6 feet. So here are our fishies. I have one fish down at 1 foot, right? And he would go right here. He is 1 foot down, so he would be 1 foot to the left on our number line. If our number line were flipped, it would flip this way to move up and down, and our 1 would be below 0. But right now we're to the left. -3 feet is going to be just past, so we hop over 1, 2, 3 units. -6 feet, we're just going to go 6 feet, and it'll be to the left, but still 6 jumps. 1, 2, 3, 4, 5, should go right here. And 10 feet. -10 feet, of course, is going to be at our -10. Maybe, if it wants to drop there. There we go. All right, and our last one would be 6 feet, which is the height of the man in the lifeguard chair. And he's going to be right here to the right past 5, because in this case, he's at above the water level elevation, so it's going to be a positive number. Let's check it out. Hey, we got it right. The next one says we want to match each elevation with its difference from 0 on the number line. So if we think of this thing as a number line, to get to 6 feet, remember we're going to go 6 units up or 6 units to the right. So we know that that's 6. But with 1, remember on our number line, if this were a number line, 0 would be the water level. That would be where the sea level starts. So this would be our 0. So if we move down to -1, we move 1 spot. Now we're moving our spot down, but it's not really a negative movement. We're just moving down. Again, to get to 3, we'd go 1, 2, 3 spots. So not -3, we want just 3. Same deal. If I'm moving 6 units, I can move down 6 units, but I'm still moving 6 units. And 10 units, -10, I would move just 10 units down. So for each one, whether we're going up or down in this case, and even though we have a negative number showing that we're moving down on our number line, we're still moving the number of spaces shown by the number. We're not moving a negative space. This movement is always positive. Check, we look great. So here we go. Absolute value is the number, is the absolute value of a number, is its distance from 0 on a number line, shown by two little lines around the number. So just like we have our 3 here, our -3, these two lines show that what we really should be reading this as is the absolute value of -3. And as we look here, we're still moving 1, 2, 3 units to get to -3. It's 3 units from 0, so our absolute value of -3 is 3. So the distance from a number to 0 on the number line is called its absolute value. Use a number line showing elevations in the diagram to help you complete the table. So the absolute value of -1, of course, would be 1 to the left, but I'm still moving 1 space. So our absolute value would be 1. I'd like you to, on a sheet of paper, or if you've got your book in front of you, William, you can do this as well, but I would like you to fill in these values. Pause the video and then we'll check them together. All right, guys, hopefully you did that. You filled in these values. So the absolute value of 6 is 6, because if we look, we're still moving 6 units. We would move 1, 2, 3, 4, 5, 6 units over. Even though it's to the right, not to the left, in this case, we're still going to have a positive movement, so it's going to be 6. Absolute value of -3 would be positive 3. Absolute value of -10, positive 10, because I'm still moving 10 spaces from 0 to get there. Absolute value of -6, still 6 spaces. As you can check, we can see that. The absolute value of a number is its distance from 0 on a number line, and distance is always positive. So question C says, the absolute value of a number is written using the symbols with the two lines around it. That means the absolute value of. For example, the absolute value of -8 is written as -8 with those two lines around it. Complete the number sentences below to show the absolute value. So again, pause here, read those absolute values, and then give me their actual value. We'll check it in a second. All right, guys, hopefully you paused it. So the absolute value of -1, again, we're still moving 1 spot from 0. It's going to be 1. Absolute value of 6, remember, it's always positive. It doesn't switch to negative just because we have a positive number inside our absolute value of symbol. So it's going to be 6. Absolute value of -3, that's positive 3. Absolute value of -10 is still 10 away from 0. And the absolute value of -6, of course, it's always positive, so it's going to be 6. There we go. All right, last thing here. The negative numbers are less than positive numbers, but that does not mean that the absolute value of a negative number must be less than the absolute value of a positive number. Well, let's look here at this set of sentences, and let's see if we can figure this out. So it says the absolute value of a negative number can or cannot be greater than the absolute value of a positive number. Well, let's see how this works out down here. For example, -7 is less than 3, right? Because well, if we're just looking at its actual value, -7 is further to the left on the number line, so it is less. But the absolute value of -7 is blank 3. Now in this case, to get to -7, I would have to move 7 spaces on the number line. To get to positive 3, I only move 3 spaces. So the absolute value of -7 is actually greater than. So that means this can be greater than the absolute value of a positive number. There we go. The absolute value of a negative number can be greater than, equal to, or less than the value of a positive number. Just depends on the number we're finding the absolute value of. All right. So we move on to our last little bit here. I want to do this last set of questions with you, and then I would like you to try some on your own. You should be ready for the review. If you want to try that out, the absolute value questions are pretty simple. All right, so the magnitude of a number is its size or amount without considering its sign. So the magnitude of a number is the same as its absolute value. So if you see magnitude in math, it's the same thing as absolute value. That just again means a number's distance from 0. So let's look at this problem. It says some insects produce a chemical that prevents the water in their body from freezing, and it also helps them survive extreme cold. An insect's supercooling point is the lowest temperature at which it can survive. The table below here is going to show the supercooling points of several insects. So I've got the phytid beetle at negative 54 degrees Celsius, the common banded hoverfly at negative 35, the New Zealand pine weta at negative 9 degrees Celsius, the pink rice borer at negative 6.8, and the woolly bear caterpillar. This beast can keep its blood from freezing all the way down to negative 70 degrees Celsius. So we're going to graph these on the number line. So my negative 70, of course, is going to go way down on the end. He is our smallest number, so he goes there. This would be right here, negative 54, because it's right by negative 60. It's our closest. If we were to find this one, this is going to be between negative 40 and negative 20. That means this is our negative 35. We're still negative for the next one. And this is between, let's see, it looks like it's between right before 10. So this would be negative 9 down here. And the next one's just a little further to the right, or further more towards the positive side of things. So that's going to be 6.8. There we go. Let's check it and make sure we did everything okay. Awesome sauce. So what is the magnitude of each number? So again, remember, magnitude is the same as absolute value. So for 70, it would be 10, 20, 30, 40, 50, 60, 70 jumps away. So our magnitude here would be 70. Likewise, negative 54 is going to be, of course, 54 jumps away. And our absolute value and our magnitude are the same. So there we go. And of course, our last one then would be, if I go down to 35, negative 35, I'm still jumping 35 units. There we are. All right. This next little bit, it says complete the values of these number sentences which use absolute value symbols to show the magnitude of each number from part B. So, of course, the absolute value or the magnitude of negative 70 is still going to be 70 spots from 0. Same deal here, negative 54, positive 54 spaces from 0, and negative 35 would still be 35 spaces from 0. All right, so here's your question, and I'd like you to pause and answer this on your own. It says, write an inequality to show the relationship between negative 70 and 35. Go ahead and give that a try, and then we'll check it together. All right, so in this case, I've got negative 70, and we want to know, is this less than, greater than, or equal to negative 35? Well, in this case, negative 70 on a number line is going to be much farther to the left. And remember, on a number line, if I'm going to the left, it's negative. It's the worst. So our number is going to be getting smaller. So negative 70 is actually going to be smaller or less than, there we go, maybe if I hit the right button here, negative 35. All right, we're almost done. So part E says, which explains best explains the supercooling point that is closest to 0 on the number line. So the supercooling point, 6.8, is closest to 0 on the number line because it has the least value. Well, it doesn't have the least value. Negative 70 is actually the least value, so that one can't be correct. The supercooling point of 6.8 is closest to 0 on a number line because it has the smallest magnitude. And remember, magnitude is the same as absolute value because, well, that is going to, its absolute value is its distance from 0, so that means the magnitude is also going to be the closest. So same deal here, since its absolute value would be only 6.8 jumps away from 0, it is going to be the closest on the number line. So let's double check. Yep, looks like that guy is the closest of all of our negative amounts there. So he is the closest to 0. He is going to have the smallest or the least absolute value, or has the smallest magnitude. There we go. And the last one. So it says choose the insect. Which insect has the lowest supercooling point? Well, we need to go back up and look at these guys again, or we can just look at our number line. So we want the coolest supercooling point, Doesn't matter about the magnitude for this one. We want to know what its actual value is. And in this case, negative 70 is by far the farthest to the left. So that it's the coolest supercooling point, or the lowest, is going to be that of the woolly bear caterpillar at negative 70 degrees Celsius. We'll check it out. There we go. This is because negative 70 is to the left of all other numbers on our number line, just like we showed you. It is the least. So the woolly bear caterpillar has the lowest supercooling point. There you go. That's basically working through the parts that we worked through together in class for lesson 1.3. Just remember, when we're dealing with absolute value or magnitude, we're just worried about the times that we jump from 0 to a number. So our number will always be positive. The absolute value of a negative number is going to be a positive value, the positive version of that number. The absolute value of a positive number is the number itself. It doesn't change to a negative because we're still jumping a positive number of spaces. Movement is always positive in this case. There you go. Remember, when you're working with story problems or working with real life things, make sure you're watching out for whether they're talking about if you're comparing two numbers or two values, for which one is bigger. Now, in that case, it would be like an inequality. Use an inequality sign to show which value is larger. But when you're looking from a larger or smaller distance from 0, then this changes. This becomes about absolute value. The smaller number, which may be a negative integer, may still have the largest absolute value if you are moving further from 0 to get to that number. I know that's confusing, but when we're dealing with just comparing two numbers' value, we want to look at the numbers on a number line. The furthest to the right always wins. If we're looking for absolute value, though, we want to count those numbers that we jump back to 0. That will show us which one is the biggest. The further that it jumps, the bigger the absolute value. Hopefully that is good for you and it clears some things up as you work through. I would check the review out, see how you do on that review lesson. And then if you're feeling good on the review, please go ahead and try that unit assessment. If you don't feel good on the review, please make sure to send me an email and I'll set up a time where maybe we can Zoom after school tomorrow or over the weekend and get you some more help. All right, guys, good luck. Hope this helps you out. Hope you're feeling better. Bye.